Big Clavern beer. Well, that's never going to end well, is it? So let's begin. Someone has sent me this rather intriguing device. Oh, hold on, beer moment. Nice. Someone has sent me this intriguing device from China. I did not order this. I wasn't even aware that you could get these from, well, eBay or AliExpress or whatever. And it came in the usual packaging. It came in the usual grey envelope. All the Chinese stuff comes in with the customs label on it. And that sort of crinkly plastic inside. So a generic Chinese mass-produced product. And my first thought was, well, this looks like a typical unit that's used with the, it's a bit disturbing, it says multi-gaming expert. I'm not sure if this is a clue. But it looks like a typical unit is sold with these muscle exercisers. And I've downloaded a picture which shows Mr. Muscles here connect to one of these things. And you think, do you remember how they used to sell that? I think they still sell them like that. And, you know, you're supposed to put pads on and it makes you all muscular with absolutely no effort whatsoever. And basically, people sat in their armchairs, plugged these things in and then decided, actually, no, they'd just stay unhealthy after all because it was quite painful and didn't give them big muscles. So it's reminiscent of the sort of cheapy versions of those, and it's also reminiscent of the transcutaneous electrical nerve stimulation devices. Now, TENS devices, to give them their abbreviated name, are devices that if you've got a muscle injury or something, or a recurring pain, you can stick some pads across it and this thing would stimulate it with pulses of electricity, and it does have a setting called numb. Not sure what that is in relation to in this particular unit though. And it's supposed to stimulate the body to send, you know, natural pain-killing agents down to that area, and it works for a while apparently, and then the effect wears off. However, this one is called SM Player. And SM is a term used in the sort of bondagey industry. I always thought it stood for slave and master. I looked online and Urban Dictionary had the first definition for SM was spaghetti and meatballs, which is jolly nice. That's actually put me right in the mood for spaghetti and meatballs. However, the second definition was sadism and masochism, which isn't so good, and then slave and master, which is what I thought it was. And looking at this electrode, it reminded me of a device I've seen before in medical sites, which is for ladies, for use after pregnancy, I think it is. And they are for, what do they call it, pelvic floor exercisers. And the idea is that it strengthens the pelvic floor because you can have incontinence problems. Not being a lady, not ever having had a baby, I am not an expert in this area. One moment, beer moment. So I went online and I looked for suitable pictures. I searched for pelvic floor exerciser and found what appeared to be bona fide medical sites selling pelvic floor exercisers. And then it all went a bit sort of weird, and there were sort of randomly shaped electrodes, and then, yes, electroshock bondage. Right, okay, this will be that one then, or similar. And it all went rather pear-shaped after that, and I discovered another electrode, which is not very convincing at all. This doesn't strike me as being a good idea. It's very reassuring to know that if you're in the electrical industry, then standard domestic cabling can be used for this purpose. But connecting yourself to 240 volts or even 120 volts, particularly with something like a 20 amp breaker in line, is probably not going to be a good idea. If you trip that breaker, you probably will be on your way to hospital shortly afterwards. Anyway, back to this. Let's take a look. Let's see what it's like. So I'm guessing that this 2-pin connector is just connecting to these plates, so let's just check that out. This is a 2.5mm jack connected to that side and connect to that side. So it really is just the two electrode plates, but this seems quite heavy actually. It seems too heavy to be plastic. So let's open it up. That's too big. So this is, I'm probably going to burst it in the process of doing this. Now, biggest concern for me about anything like this being inserted into any part of your body would be, oh, that's not working out so well, would be the possibility that if you apply DC current across flesh, it actually damages the flesh. This is chewing up that screw in there. I don't think this is coming out. Is this coming out? Is it coming out? Or am I on to plums here? No, it's coming out. It's coming out. That's good. If you apply DC current, if I was to just put this across a bench power supply and I was to hold it in my hand for a prolonged period of time, it would actually leave injury. It would actually leave perforations in the skin because it causes DC, what I used to think was called electroporosis. I think it's got a different name. I'm not sure. I tried searching for electroporosis and didn't find it. So that's a concern of putting anything in any part of your body. Oh. And certainly the original muscle exercisers, like these things, used to use little transformers in the output that applied AC. So it was always a sort of, you know, oh, there's what the weight was. They applied AC through a transformer, so it was always symmetrical waveform, so to speak. Whatever current went in one direction would go in the other, so to speak. Some of the little muscle exerciser, particularly the little cheapy ones they used to sell that stick on, the sort of like the butterfly shaped pads that were sold at places like Poundland, just use a little inductor to actually fire spikes, and they were quite sore to use. I don't know what's in this one. I'd guess it might be the same thing. So what we've got in here, we've got the two wires going in from that connector. We've got them going to one electrode on each side. I have to say, maybe it's just a paranoia, but as soon as I saw what this was, the first thing I did was thoroughly wash this electrode, and I'm glad to see that water hasn't got into it. It seems to be quite resilient that way, because yeah, it's just got that sort of element of, even though it was brand new from China, it's just had that to it. So not much there. There's a weight to make it heavy. I think it's a weight. It might be a piece of plutonium. I doubt it though. That would be actually worth getting just for the plutonium if it was. That's not necessarily a good thing though. Someone recently mentioned to me that, you know, the stuff that comes from China, you should check it for radiation. Should I check this for radiation? Because some stuff that was made of steel, and in particular I can recall an incident where Otis elevators have had a batch of their button controllers, you know the button you press to call the lift, they were actually slightly radioactive. I'm slightly paranoid. I'm just going to check that now, one moment. Fortunately I have a Geiger counter. Oh, a very dusty Geiger counter. I'll just wipe the tube off before I actually power it on because it will get potentially up to quite high voltages. Right, so ambient radiation is quite low. I'm not getting anything that would hint at actually being radioactive. So that's a good start. What about this? Nope. What about this? Nope. What about this? No, nothing really radioactive. That's good. That's fine. I'll just carefully pick this up because it is now charged up to several hundred volts, because that's what Geiger tubes work at. So, this takes two AAA batteries, which I've already loaded. The back says product name SM Player model SM69. The 69 is a bit of a clue as well. Voltage 3 volts. Out power pulse max 100 volts 20 milliamps. So I'm not sure where to try this out. Let's actually try it out. Turn this to minimum. And I'll try it in my hand. This is where, when I turn it on, immediately goes to full power. Okay, an LED is lit. Pulse. Anything happening? Oh, it is. It's showing a little LED pulse. I don't feel anything yet. I'll turn it up. Not feeling anything. Oh, wait, no, I'm suddenly feeling something. Oh, that's quite unpleasant. That is sharp, stabby, tingly sensations. Turning it up a bit higher. Oh, it's ballistic. It's going actually up beyond. Oh. Okay, so let's turn that back down a bit. Oh, it doesn't actually go down instantly. It actually seems to have a ballistic response. What about numb? Yeah, that works. Oh dear. Oh. Right, let's try this again. That's it set to minimum. Let's turn it slowly up. Oh, that is quite a strong tingling sensation. That is quite unpleasant. So what does the adjust button do? Does that make it stronger? I think it's varying the I think it's varying the sort of cycle. Right, okay, that's quite sore. Absorb. Let's turn it down before I do this in case it's something violent. Okay, that's just ow. Oh, I'm not liking this much. Hold on, more beer. Liquid courage has been applied. Let's turn this down marginally and then grab hold of it again. So the question is, well, we'll take a look inside this afterwards. Let's turn that way down. Technically speaking, I could measure the voltage across this. Oh, there's an idea. Unless it's actually, I wonder if it has that cut-off system that it actually turns off if the electrode is disconnected. I suppose there's one way to find out. So that is now putting out a strong tingle, but it's very sharp and spiky. It doesn't feel like a sort of like a mains electric shock, which is all smooth and rounded and violent. Let's see if we can measure anything in this then. Let's stick this to AC volts, which would be the ideal scenario. Let's set it up about 200 AC volts. Gonna get anything? Ooh, am I getting a good connection here? Well, I'm definitely getting a good connection. Right, it seems to be, it's kind of integrating the pulses a bit. I don't think that's what it's actually seeing now. More importantly, I want to see if there's any DC bias to this, so let's turn it to that and see if there's a DC bias in the output, because that would not be good. Oh, look at that, it's alternating the polarity. So it's doing positive pulses and then negative pulses. That's unexpected. Yeah, that's odd. I wasn't expecting that at all. Right. So let's take a look inside this unit. Let's turn it off gingerly. Pop the batteries out. Ugh. And pop the cover open and take a look at the circuitry. I wonder what it's using to get the different polarity. Now, as I say, traditionally the muscle exerciser units actually used a small, what looked like an audio transformer. Just a small cube, about 20 millimeters, 3/4 of an inch sort of square. And latterly, the cheaper electronic devices used the little inductor. And the concern, as I say, is if you apply something with a DC bias, it's not what I've seen before. It's actually using a little chip. Does the chip have a number on it? Does it? Hell. They never do they? Just none of these things has a number on it. That's annoying. Let's hike this out. Oh, really not much. There's an inductor. Lots of transistors without tracing out. I like the use of the large 0 ohm link across there. Potentiometer, little capacitor, inductor, the push buttons, and the rest of it is just on this side. It's this anonymous chip. It's the inductor is here. Is it being pulled down just by that chip? Oh, it's that. Oh, the battery connection is going to this end of the inductor. The output of the inductor is then possibly being used to just boost a voltage up, which then might be actually being switched by an H bridge. One moment please, I'm just going to investigate this. A bit of beer and doodling later, and this is what I've found. This transistor is being used in conjunction with an inductor to step up the voltage, and it goes via this diode and charges the capacitor. So it generates a higher voltage on the board for this sort of stimulation of the muscles. And then it does, in fact, use an H-bridge driver. It's got two of these transistors are connected to the positive rail, which is coming through this link, and two of the transistors are connected to the negative rail, which jumps through these other links onto the negative rail. And each of the output connections has a connection to a pair of those transistors, so that the output can either be turned positive or negative. So in the case of the electrode here, when this side's positive, that will be negative, and then this one will go positive and that will go negative to give the sort of polarity reversal effect. And if I just do a quick, well, I've got a bit of a doodle I've started here. We've got the transistor is being driven by pulses from the control chip, and the inductor at the back of this is pulled down by this transistor. So this transistor here is pulling this end of the inductor down. The other end of the inductor is connected to the positive rail here. When the transistor turns off, you'll get a high voltage spike, and that then goes through this diode and to the capacitor, which is behind here, and it's a 1 microfarad 50 volt capacitor. So that generates a sort of high voltage bus rail, which I've measured. It peaked at about 100 volts, which is a bit foreboding given it's a 50 volt capacitor. The output then goes to that H-bridge driver, which basically has, each of those pins has the transistor driving it either positive or negative, and it's got two sets of those. I won't draw into too much detail just for speed. And the other two transistors over here are actually level shifters. They're used from the chip to actually switch these upper transistors because they're switching to sort of a much higher voltage rail above the chip's level. That leaves one more transistor on this board, and it's this one down here. And this is quite neat. To save space on the board and the number of pins required, they've used one pin to not only control the LED but also read the button. So when this transistor's on, it energizes the LEDs. It pulls them via this resistor here to, is that negative positive rail? I'm guessing it might be the negative rail. But when that transistor turns off, then it can actually read the input from the LED, the switches, and it just means one input is one switch, one pin can do an LED and a button. It's a fairly straightforward arrangement. The potentiometer looks as though it feeds back to the chip for just a sort of control signal, maybe an analog input, and it then probably just controls the pulse ratio to the step-up circuit. So let's measure the voltage across that. So if I stick this electrode in and hold it, this is where I get zapped again, isn't it? Blech. Oh, let's not turn it that way. That is turning it up to the maximum level. That's not good. So I'm going to cautiously, and this is, oh actually no, this is going to hurt so bad. Let's turn it on by touching a bit the circuit board that doesn't get up to modest voltages. Okay, and let's activate that circuit. So is this going to give me a zing? No, it's not. I have to be careful. I touch here so I don't get zinged. So let's turn the voltage up until I can feel it. Am I even turning that dial there? I'm being a bit ginger because, you know, it does suddenly go up suddenly. And also my other finger is very close to the other connection. Oh right, okay, I can feel it stabbing. Yep, Let's bring the meter in and measure the voltage across that then. So if I hold, I'll hold a positive lead. That is getting sorer. Ah, that's about 60 volts. What if I grip it tighter? The voltage goes down, and if I let it go completely, the voltage actually is holding a fairly constant voltage, isn't it? So it is being loaded down when I'm holding that, but it's not floating up too high. What if I then cheat? I don't know if this can sense the voltage or the fact the load is not connected. The voltage has gone floated up quite high, hasn't it? So if I turn this potentiometer, oh no, it's just shut off, hasn't it? It has shut off. or if I just, no, it's not shut off. So if I turn this up higher, I think it's regulating to a degree, is it? Oh no, it is, it's going up quite high, isn't it? So open circuit, it goes up to quite a voltage. It goes up to about 120 volts, but at current limited. That might also be why there was a ballistic response, that when I turned it down initially, it didn't seem to be going down that fast. That must be because that capacitor was taking a wee while to discharge, which means that the amount of current actually firing through that is probably quite low. Yeah, my hands are sweaty now. Even at the lowest setting, it's quite noticeable. Okay, so that's an interesting bit of circuitry. I should just pop the battery out. That's the best way to turn it off. There we go, it's safe now. So that just leaves the question. I'm kind of intrigued in the sort of clear intended fetishy application for this, but that might be lowering the standards of the channel just too much. Not that it could be lowered that much lower than I've lowered it already. So I'm going to leave the decision to you guys. I'm not going to obviously stick it up in this video. So you guys are going to have to make the decision. That's it. I'm just going to put the ball in your court. If you think I should stick it up there, give me a thumbs up. If you don't think I should do it, then gives me a thumbs down. Therefore, that puts the onus on you, the responsibility on you for this act of perversion. So yeah, make your choice. Thumbs up for yes, do it. Thumbs down for no, don't, because that is obviously a sin. But yes, interesting device. Quite a neat bit of circuitry.